little bit behind on attendance here. All right, welcome back. Haven't seen you guys in a while, with last week being a 4-day week and Friday being another B day. So kind of flip-flops. Last week there was 3 B days, and then this week there's basically 3 A days, since Friday will be an A day, and you'll kind of, sort of have 1 B day because tomorrow is ACT testing. So if you're not aware of that, make sure you speak to your advisor about that, see what your plan is, whether you're testing or not, or where you're testing, or where you're relocated to. Okay, so today we are going to continue section 3.2, which is where we first started logarithms. So last time I saw you guys, we talked about how to know what a logarithm graph looks like, and we talked about a couple logarithm properties, and then today we're going to practice some of that in worksheet 1 together as a group, and then worksheet 2 do on your own as guided practice. And then we'll look at worksheet 3, which is number 89, which just touches on a couple of the harder concepts and reinforces a little bit of it. Then I got a few things for you to look back over, because we will quiz this next time at the start of next class. So that would be Wednesday for us. So of all those things I'm going to ask as you review, certainly these worksheet 1, worksheet 2 that we're about to look at is going to be not exactly like the quiz, but the one that's the most similar. So with worksheet 1, what I'd like to do is do a little bit of reminders, a little bit of reteach on it, one section at a time. And then after we do that section, I'm going to ask you to do the same section on worksheet 2, which is just the back. So that way, if it's not clicking right after we just reviewed it, then that would be a red flag that you need to come in and try to get some help during advisory or spend some more time on it. Okay, so the first little section we're going to look at is questions 1 through 12 that ask us to simplify these. And I'm going to jump around here a little bit. I'm going to try to focus on one property at a time. So starting with question 1, just because it's first. The most important logarithm property is the one when you have an exponent on something you're taking the log of. You need to know that you can bring that exponent down. Sometimes we even bring it up, but 99% of the time we bring it down. And then 2, you need to know how to evaluate a logarithm. Log base 2 of 2 is saying 2 to what power gives you 2. So all of that becomes 1. And so your answer comes from 7 times 1. So as long as you know you can bring the exponent down and you know how to read a logarithm, certainly don't need a calculator here. Now, the next thing I want to do is kind of jump around in questions 1 through 12 and try to identify all of them that use this property, because this comes up a couple more times. So number 2 doesn't look to be set up the same way, but number 3 does, because x is an exponent on something you're taking the log of. So you should bring x down out front. If natural log is not something you're familiar with, remember it just means log base e, so you're welcome to rewrite it. And so then this ends up being 1, 2, because it's saying e to what power gives you e. So your answer comes from x times 1. X. So we're not solving equations here. I'm not trying to solve for what x equals. Not answer is going to be a number. It could also be a variable. But 1 and 3, you need to see how those two are the same. Okay, scanning ahead, I think I see one more on question 11. One more that fits this pattern. 5 is an exponent on something I'm taking the log of, so 5 can come down out front. Log base 4 of 4 is one that we should be able to do in our head, because 4 to the first gives you 4, so your answer comes from 5 times 1. So if you can do one of those, you can do any of those. Same thing, just on there multiple times. Okay, And then resetting, let's go back to question 2. So 2 does not fit the same thing. This one is kind of a little bit different. Its property was when you have a number to the log and base is the same number of something, all of that just simplifies out to be the something. So 3 to the log base 3 of 8 is just going to be 8. One of the easiest questions you can do, but you do have to recognize that pattern. Okay, looking ahead, I see this 2 more times. Question 6 is one of them. This is e to the log base e of 5. So it's all going to simplify to 5. And also 12. 10 to the log base 10 of 7 would just be 7. Okay, and then we already did question 3. Now I feel like if you can apply those 2 properties and finish those 2 questions, a lot of these others are going to be kind of gimmies because they're set up to be a lot easier. We've already talked about natural log of e just means, or natural log means log base e. So this is just really 5 times 1. Once again, natural log just means log base e. E to the 0 gives you 1. Number 8, if there's no base written here, it's an understood base 10. 10 to the 0 gives you 1. Anything to the 0 power gives you 1. These are basically the same question. Over here, this is negative 2 times 1, because natural log of e is 1 for the 5th time today already. Number 10, 10 to what power gives you 10? And then the one that I think is a little bit harder, after we do section 3.3, I can give you an option on how to approach this one, but temporarily the only way for you to work this one is to rewrite this with exponent rules. A positive 2 in the denominator is the same thing as a negative 2 exponent in the numerator. The reason why you should do that is because now this is an exponent on something we're taking the log of. It's just like question 1 at this point. And you're left with negative 2 times 1, which is negative 2. Now, not that this is super pressing right now, but we did also decide to split up this test. So once we quiz section 3.2 on Wednesday, we'll move into test review and do just a 50-point test over 1.9, 3.1, and 3.2. And then we'll move on to 3.3 and 3.4 and do another 50-point test. So I think that's really in your interest because it does break it up and make it much less content for 100-point test. Okay, so what you need to do, of those that I started off that you would not have thought of on your own, you might want to circle those questions as a quick little resource, but then flip your page over. And I would like you to try the same section, same question types, without flipping back and forth. Just see how you can do, because if we just talked about these and it's still, and you're still missing it, then that's exactly what you need to review. So let me give you a couple minutes to fill out those 12. I will share the answers and we can go over all of them if we need to, or we'll just go over the ones that y'all need me to. Bless you. Give everybody one more minute and then we will check and move on. Okay, so as I said, I'll go over all 12 of them if you need me to, but let's just start with the answers first. Looks like it should be 1, 6, A, 2, 0, 2, -3, 2, -4, 0, 3, and 5. So which of those would you like me to explain, go over? We're good with all those? Okay, I'm going to highlight one of them right here. Your answers don't have to have numbers in them. I think on our quiz, there's a few questions that have X in the question, and you have X in your answer. So just like this A is some generic number, I guess. Your answers do not have to be numbers. Okay, so let's go back to the other side and let's work on the next little section here, and we'll do the same thing. So 13 through 18 are all solving equations, and I think I gave you a heads up that in section 3.4 we only solve equations, so we go much more in depth. But right now there's really only a couple ways you need to be able to solve, or 3 ways. One is using a property that we'll see in question 14. So taking basically what we did in questions 1 through 12 to simplify this and make it look much more manageable. 2, if both sides of an equation have the same type of logarithms already, then that part's already balanced out. And 3, the hardest ones would be switching forms. If you have something in logarithmic form, sometimes you want to switch it to exponential form. If you have something in exponential form, sometimes you might want to switch it into logarithmic form. Okay, so question 13 would be the first one that I've said. If you know how to simplify this and you understand that that's just 1, then you're pretty much done. You've got a couple basic algebra steps to be undone, but nothing major. Okay, same idea with number 14. If you look at all of this and you realize that this comes out to be 8, which is really a skill from questions 1 through 12, then you're left with something that's reasonable to do in your head. 2 to what power gives you 8? Just be careful not to say 4. It's not multiplication. It's exponents. 2 times 2 times 2 gives you 8. 2 to the third gives you 8. So again, sometimes just simplifying these rewrites it in a way that makes it look nice and neat. One of the other 3 I said is sometimes the logarithms are already balanced out. So like this side says natural log, this side says natural log, so we already have those to be equal. So then we just need to make sure that the inside stuff is equal as well. And then solve like normal. Now the one kind of tricky thing about this that may make you miss one question on the next page is that with logarithms, Remember, these can be extraneous. So it's not that I did anything wrong here, but you do need to actually plug it in to the left side. 24 minus 6 would be 18. Plug it into the right side. And make sure that you're not taking the log of 0 and you're not taking the log of a negative, because that doesn't make sense. Since 18 is a positive number, I'm not taking the log of 0, I'm not taking the log of a negative. So 6 is my answer. Okay, same thing with 16. This is already log base 2, and this is log base 2, so that part's already balanced out. So just set the insides equal to each other, divide both sides by 6, and then plug it in to make sure it's not extraneous. You can have 0 as an answer, you can have a negative number as an answer, but when you plug it into the original equation, you should not be taking the log of 0 or the log of a negative number. And since 1/2 is positive, there's nothing wrong with that. Come back to 17, because this one is kind of the challenging one here. I think on the back, I think 17's the one that is also challenging on the back. But number 18, this is already log base 10, this is already log base 10, so we just have to make sure that 2x equals 6. So it looks like x equals 3, but again, make sure you plug it in to make sure it's not extraneous. It looks fine. It also checks your solving too. If this had log of 5 and this had log of 6, those are not equal, so you would know something was off. Okay, 17 takes a little bit more thought. This one, I basically did one step of logarithm and then solved normally. One logarithm step and solved normally. Thought about logarithms at the end, and otherwise they were balanced, so I didn't really even do much with logarithms here, here, or here. But with 17, I can't do this one so quickly. First thing you need to understand is that the answer is going to be a fraction or a decimal, because the answer is bigger than 1, because 8 to the first is only 8, and I want it to be 16. 2 is too big, because 8 squared is 64, and I only want it to be 16. So with very little effort, you should know your answers between 1 and 2. But that's what makes it hard. This answer is not a nice whole number, so we actually have to slow down and think of this a little bit more carefully. So you are welcome to do this in any way that you would like to, but what I find that works the best for people is to do this in 2 steps. I'm going to raise 8 to 1 power to change it, and then I'm going to raise it to another power to get it to the 16 that I want it to be to. Okay, so for this, you have to remember that, do you remember how an exponent of a half is like a square root? Remember saying that? No? Okay, y'all need to know that. Something to the 1/2 is like square root. So something to the third is like a cube root. Exponent of a half is like a square root. So if I raise this to the 1/3, the cube root of 8 becomes 2. So I raise it to the 1/3 to kind of break it down to a smaller whole number. Because then once I've done that, then I can say, well, 2 to what power gets me to 16? And that would be 4. 2 times 2 times 2 times 2 is 16. But what I really want to do is both of these at once. So if I want to raise it to a third and to the fourth, we're raising it to the 4/3, which is between the 1 and the 2. So if you want to break it down by cube rooting it, raise it to the third. If you want to break it down by taking a 4th root, raise it to a 4th. The most common one would be raising it to the 1/2 to do square root. But break it down to get it to be a smaller number, and then it's a little bit easier to do. So that tends to be what I think is the easiest approach. Okay, same thing. You might want to star a question or two that you think you might want to review, but then flip it over and try those same 6 question types for me, 13 through 18. Okay, here are my 6 answers. I would think number 7 might be one that you need to ask about because it's more difficult. And number 15 is easy to miss if you're not careful there. It's easy to think the answer there is -6, but -6 is extraneous. So, of these 6, which of these would you need some help on?
Can you do 16?
16? Okay, so we've got log base 2 here, but also log base 2 here, so that part's already equal. So 5x equals 1/3. So divide both sides by 5. 1/3 divided by 5 would be 1/15. Is that enough?
Yes.
Okay.
Thank you.
Everybody okay with 15 and why it's no solution? You guys okay with why 17 is 3/2? Any of the others? 13, 14, 18? Okay. Then let's look at the last section, which focuses on graphing. So question 19 says find the inverse of y equals 2 to the x. So this is just one that you should have memorized. That would be log base 2 to the x. And I guess I should probably use inverse notation. So when we did 3.2 notes part 1, the first few questions were about this, and I tried to emphasize how you really need to know that to help you graph some logarithm graphs. So on question 20, I want to know what this logarithm graph looks like without a calculator, and if I graph this wrong, I'm probably going to mess up some of these characteristics about the graph. So graphing this is very important. So the point of asking you question 19 is if you can graph 2 to the x, so 2 to the 0, 2 to the first, 2 squared, 2 to the third, it's exponential growth. If you know what 2 to the x looks like, and you understand that log base 2 to the x is its inverse, and you remember what it means to be inverse, it just means x and y are switching. This point moves here, 1, 2 becomes 2, 1, 2, 4 becomes 4, 2, 3, 8 becomes 8, 3. Then you know what log base 2 of x looks like without needing to memorize anything else. This is why we did inverse review before we moved into exponential functions. This part's not important right now, but remember there's this line of symmetry of y equals x if they are inverses, so it's good to see that. And then finally, if you can do that, that's its parent function. Adding 4 to x will shift it left 4, as long as you're not reflecting over the y-axis and then the rules switch. So if I've got these points and I know mine needs to go left 4, just move all of your points left 4, replot them. Take your vertical asymptote, move it left 4. And then we've got the graph that we need to be looking at. Make sure if you have more than one graph on your page, you label which one is your answer. So like I'm labeling this f of x, this is what they're calling it. Or you can erase your other graphs, but don't put 3 graphs on there, and I can't just assume that the correct one is what you thought it was. Okay, now that I've got that in front of me, I can see his domain. Describe the x values that it approaches. Approaches -4 on the left and infinity on the right. Range, describe the y values. He goes down forever, and he does go up slowly here, but he does go up forever. The asymptote for this type of problem is vertical, so x equals that number he's trying to approach on the left would be his asymptote. Asymptote is the number that it approaches but doesn't get to touch or cross. X-intercept looks like it's at -3, and since I was careful with my points, I got a few points from 2 of x, switched them to get exactly a couple points on log base 2 to the x, and then moved them left 4, one of those happened to be exactly what I needed, so it was good that I kept up with some specific points. Likewise, the y-intercept, I can tell it's going exactly through 0, 2. But here's what you should do. This actually happened in my B-Day classes last week. My graph was a little bit off because, of course, it's just a sketch. So I wasn't sure if it went through 2 or a little bit bigger than 2. If you have any doubt at all, or if you just have time, you should solve this algebraically. Just plug 0 into the function and solve for y. If it's supposed to be a nice whole number, then it should solve easily. And log base 2 of 4 would be 2, because 2 squared is 4. So it doesn't take you but 5 seconds to check it algebraically. And then 4 looks like it goes through 3, but same thing. Probably a good idea to check, because if it's not right, if it doesn't look like where my graph is, then I would know to maybe spend more time on my graph, because I might be missing some of these other questions as well. So you can always plug in the next value and solve for y, and especially if you expect it to come out to a nice whole number, then the logarithm should simplify nicely. Okay, so mark down what you need to from that. Flip over one more time for worksheet 2 and try those before I share the answers. let's give everybody another minute to try to get caught up. Yeah.
Is it supposed to be log 2 of X on that?
Yes. What part's messed up?
I just got confused because on 19 it said 3 of X.
Okay. That's true. It was testing you that, but this was log base 2. So I was still using 2 of X. I mean, I almost did the same thing if you were watching me, but wrong spot. Okay, here are my answers, and let me give a brief description of each before you look them over and see what you need to ask. So 19, yes, it's true. 19 has nothing to do with question 20. Just trying not to give you the exact same question. So the inverse of 3 to the x would be log base 3 to the x. But in 20, this was log base 2. So I still graphed 2 to the x, switch x and y to get some points on log base 2 to the x, and then I shifted it left 8 because that was the transformation. And so here's what your final graph should look like. And again, that's the most important part. If your graph looks different, then you're answering different questions here. But domain approaches -8 on the left, infinity on the right, goes down and up forever. This asymptote is right here. It's a vertical line, which is why it's x equals and not y equals. Asymptote is always the line that it approaches but doesn't cross. The x-intercept I was sure about because I kept up with that point. The y-intercept I was not sure about. To me it looks like it's between 2 and 3, and I certainly should not guess 2.5. So I actually went down here and solved for it. I knew if I wanted the y-intercept, x would be 0. So I plugged 0 into the equation and solved. Log base 2 of 8 would be 3 because 2 to the third. So this actually should look like that. That's why we can't trust our quick sketches. And then -4, 2 was a point I kept up with, so I was pretty safe about that one too. Although this one and this one, you could check algebraically. You're welcome to plug in 0 for y and solve for x, or plug in -4 for x and solve for y. There's no reason to just hope that those are correct. And again, if your graph's wrong, like maybe you accidentally went right 8 instead of left 8, if you plug in a few of these points and check, then it should be consistent with what you have. Okay, which of these would you like me to go more in depth on? We're good with all this too? Okay, so again, I am going to remind you of some other handouts you should look at to prepare for the quiz, but this would probably be the most important one. Your quiz is not going to look exactly like this, but I would say the majority of your quiz looks like worksheet 1 the front or worksheet 2 the back. Okay, let's move on to worksheet 3, last thing I've got for you today. So some similar stuff, but also a couple of the harder things that we had talked about in the notes. And I actually like to do this one backwards. I think it makes sense to start with question 3, then go up to question 2, and then finish with question 1. Okay, but you still need to know your transformation rules. Transformation rules still apply to logarithm graphs. So if you add directly to x, it's going to go left that much. If you multiply the parent function by a negative, that's going to reflect over x-axis. And if it's got a +2, he also goes up 2. It's going to have more than one transformation. And then these two are easy to mix up. If you multiply your parent function by a negative, just like this one, it flips it or reflects it over the x-axis. You should always try to say reflect instead of flip, by the way. I know the action is flip, but flip is not a math transformation. Reflecting is a math transformation. But if the x is only on the negative or only on the y, that is how it flips or reflects over the y-axis. Some people need to mark those two because those are easy to switch up. But that's not anything new, which is why I'm not spending much time on it, but it does show up on the quiz on a handful of points, so make sure that you've not forgotten any of that. Okay, and if you don't know what the transformation rules are, then graphing some of these equations like these, I know this says find the intercepts also, but we're not going to do that. We're going to just graph them. We already talked about how to find the intercepts on the other handout. So if 2 to the x and 3 to the x and 5 to the x and e to the x all basically look like this, then the inverses, log base 2 to the x, log base 3 to the x, log base e to the x are all basically going to look like this. So log base 3 to the x. Again, what I could do is graph 3 to the x, switch the points around, xy becomes yx, and then we've got a pretty accurate log base 3 of x. This transformation should shift it left 3. So shift over all these points. Oh, that's bad. And then that's how you should know what that graph looks like. Of course, you could always plug in some points too. Now, if you plug in x equals 1, it's not going to be a nice whole number, so that's going to be kind of hard to figure out. But like if you think 6, 2 is a nice whole number it goes through, that means you should be able to plug in 6 here and evaluate this and see that it comes out to be 2. So knowing what a logarithmic graph looks like, knowing specific points by the exponential function, switching x and y, and then applying the transformation rules. Okay, in question B, I get to take some of my same work from before. I already know what log base 3 of x looks like. And then it looks like I just need to flip him or reflect him over the x-axis. So anything on the x-axis is going to stay on the x-axis. Everything else flips over. So that's what that graph would look like. Okay, I'm going to come back to C because this is the one I'm most worried about. I know we talked about it in your notes last time, but it's been a while and that's just a harder one to get. So question D, it's got log base 3 of x as the parent function. Same one as from the last 2 questions, so I can just kind of steal that. I don't need to rethink about that. But now the plus 3 is not directly to x, it's to the parent function, log base 3 of x, so that shifts it up 3. So it should look like that. Okay, and then to finish off the graphs, going back to C, he at least starts off with the same parent function, log base 3 of x. But one thing I'm concerned about is if the negative's directly on the x, that flips him over the y-axis, not the x-axis. And the biggest thing that I'm concerned about, again, I put this in your notes, so this isn't the first time you've heard it, but when you reflect over the y-axis, the transformation rules for left and right, this is a positive 3, which usually means, oops, if you add 3 to x, that usually means left 3. But when you flip it over the y-axis, those rules switch. So it's actually right 3. It's like this negative's going to the x and to the 3. If that bothers you, the way those are written, you can just switch those around, by the way. This is like negatives going to the x and this, so that's why it's actually a right 3. That's the one that I want. So, of no fault of your own, that just doesn't come up very much in Algebra 2, but you do need to know that. you reflect across the y-axis, the rules for left and right transformations are opposite of what you're used to. Positive 3 normally means left 3, but because we flipped it over the y-axis, it's actually right 3. And you're welcome to graph that in your calculator to confirm. Although our quiz will be no calculator. You can't rely on the calculator to do it for you. Okay, so with this in mind, this is why I wanted to do question 1 last. Question 1 gives us this. It doesn't say we have to graph it or anything, but if we can see the graph, then knowing the domain and where the asymptote is going to be a little bit easier. So this is like log base e. So we just did a lot of questions that are log base 3, but remember all logarithm graphs basically look the same. So this is what natural log of x looks like. If I deal with the negative, I know he's going to flip over the y-axis. So this is what the natural log of negative x looks like. And then this positive 1, adding 1 to x usually goes left 1, but because I flipped it over the y-axis, this is actually going to go right 1. So this point moves right 1. Now I can see the domain is negative infinity to 1. Oops, sorry, that's the domain. And he stops here at 1 because that's where the vertical asymptote is. Vertical, so x equals, and x equals 1 is the number he approaches but doesn't cross. But once again, when you flip over the y-axis, the rules for left and right switch. If 1 minus x bugs you, remember that you can switch the order of those. That's the same thing, which is the same as this, which is why it's right 1. The negative goes to the x and the 1. That's why it's hard to see the it's right 1 instead of left 1. So I just think that's one of the trickier ones, but it would be fair game for the quiz or the test. So finish up that up, please. We still got almost 30 minutes here. But the things that I suggest that you look over would be your 86, which is where we did notes part 1 last class. That was specifically on graphing. Notes part 2, which was 87. That was a little bit longer, and we talked about some of the properties and did some examples. And then 88 that we did this morning, which was worksheet 1 and 2. I would say that would be the first one I would make sure I was comfortable with. And then 89 was worksheet 3. Quiz will come from those topics. So while all this is fresh in your head, you might go and at least mark up what it is you need to review. But again, you have almost 30 minutes here, so you could probably make a dent in your studying if you need to study. So after this, we will kind of stop the unit temporarily. Wednesday we'll quiz, Friday we'll test review, next Monday we'll test. But it's only going to be over 1-9, 3-1, and 3-2. We're splitting it into 2 halves for you instead of one big 100-point test over 5 sections. So hopefully that makes it a little bit more manageable. But keep in mind that after this test, 3-3 and 3-4 are still about logarithms. Still logarithmic properties. A lot of this stuff is going to carry over. So of course you want to do as well as you can, but the better you know it, the easier the next few weeks will go as well. Okay, and that's all I've got for you. So if you think of anything I can help with, then please let me know. Okay, and I am going to be asking for 2 of these handouts to give you some participation grades. I feel like we've done all of it together in class, but still want to give you some points for that. And I just put those in Google Classroom, so if you want to turn them in early, you can. Of course, if you don't, just make sure you have them ready to turn in before we start the quiz on Wednesday.